Good morning, everyone. Thank you for joining today's webinar on building condition assessments. This webinar is primarily focused on proactive maintenance of building envelope type assets on commercial buildings such as exterior facades, exterior and interior paint, roofs, flooring, those kind of assets. So if your job involves management of these type of assets, we trust you will gain some information today and that will be helpful to you in your work. So learning objectives today is to become familiar with the basics of building condition assessments, understanding how to incorporate condition assessments into a facility management plan, and observe how to prioritize spending on maintenance of assets for an individual building or portfolio of facilities. So the purpose of today's webinar is to discuss an engineered approach to management of untagged assets. So a planned approach provides data to know when maintenance dollars should be spent at the optimal time. Facility managers need a plan to prioritize spending of maintenance dollars on assets at the optimal time in a proactive manner, not managing reactively when removal and replacement is required, as illustrated in that top photo in the slide. So to discuss a maintenance planning for a single facility or for a portfolio of facilities. In the current environment, data collection may need to be done remotely or when travel restrictions or quarantine prevent travel, so maintenance prioritization and planning can continue. So when we manage our facilities, there's a lot of questions, right? So, who is responsible for maintenance, or what assets require maintenance, or what untagged assets do I have, or what service environment are the assets in? What is the condition? What is the appearance? What are my maintenance priorities? When is the optimal time to maintain an asset? When does my warranty expire? Where should maintenance take place? Why is maintenance required? And then how much is the maintenance going to cost? How much should I budget for my program? And how should the asset be maintained? Should it be overcoated or overlaid, or does it require removal and replacement? So the facility condition assessment process, it primarily it involves around 7 steps. So we've got those here on the screen. So step 1 is basically breaking down the facility on a component level. So this does require discussion with the owner. Step 2 is to collect the condition data. That could be done remotely or by a qualified inspector. Step 3, conduct physical testing of assets to help determine the asset condition. Step 4, analyze data using deterioration curves to determine the optimal time for maintenance. Step 5, establish the maintenance plan for per facility or on a component level. Step 6, determine the future value cost and propose maintenance schedules. Step 7, determine proactive maintenance schedules throughout the asset's life cycle and determine the portfolio summary. So some general information as we at the onset of a facility condition assessment, there's just general information we obviously need to gather. The facility name, the facility number, location, the contact information. Also, building plans and specifications as built documents are important if they're available, such as elevations, floor plans, wall sections, mechanical drawings, those kind of documents. Also, the interview is very important, interviewing the facility contact prior to arrival. And that could be done face-to-face or, remotely. But it's basically a meeting with the facility contact to discuss, some basic facility assessment type questions. The facility contact has been there in many cases, has probably been there for many years and would know the facility obviously a lot better than you would. So getting their input into what their pain is or what issues they're having is important. And so asking certain questions, about what issues they may be having and documenting those discussions is an important part of the process. So step one, establishing the asset matrix structure. So it's basically a process of subdividing the facility into a component type level for collection of asset condition data. This step does require, a lot of coordination and discussion with the owner to develop a matrix that's consistent in how the owner views the facility or what attributes are important to the owner, because it's not necessary to collect data on things that are just not important or drive decisions. So this is a very important step. So there's several ways to establish a maintenance structure. It can be a basic structure, standard, or a detailed subsection of the facility. So we've got an example here on the screen of how a facility could be split up into by components. So and this is kind of how we've done assessments in the past. So a region could be like it could be all facilities nationwide, or it could be divided by state or district, and then the area a lot of times is at the actual facility. So if we're comparing, several facilities in a state, that could be segregated out in the summary or portfolio summary. The sub area could be or is usually like the exterior or interior of a building. The grid typically is divided into maybe the elevation, like front, right, rear, or left, or quadrant. So it could also include like auxiliary structures or, interior. So the item is usually a major category, such as a wall or sealant or miscellaneous. And so the sub item is actually the component level. So we've got in the exterior example there, we've got some precast, we've got split face, smooth face, and accent branded corner, which may or may not be important to some owners, and then some ICB. And so for flooring, we've got carpet, ceramic, LVT, VCT, and concrete. So just some examples of how a matrix could be set up. So the data collection. So this can be done, remotely or on site. So in today's environment, collecting asset condition data, may be done the traditional way by an engineer or facility consultant or a qualified inspector. If travel is not possible due to restrictions from quarantine, remote options may be necessary. So remote options may include using a local liaison, such as a facility associate powered with some type of technology like FaceTime or GoPro or a mobile app. The local liaison is typically directed by an off-site engineer or consultant directing the assessment data collection. So this allows for assessments to continue during quarantine. It lowers costs due to travel and decreases the time required. Traditional on-site data collection is still practiced and does allow for a somewhat a higher degree of accuracy and consistency, and can uncover some unique nonconformities that may not otherwise be noticed. So, but in the future, it's likely that data collection will consist of probably a mixture of remote and on-site data collection, as the pandemic has taught us ways to do things differently than we've traditionally done in the past. So collecting the asset condition data remotely. So there's a few resources or that's available. Google Satellite is obviously a resource that we can use. Drones is one. Firms are using a new concept now. A lot of firms are using a new concept called drone communities. It's an access to a network of local drone pilots that can actually go out and survey a building for a pretty economical cost. 3D point clouds, it's basically a 3D visualization of a space using made up of thousands of dots. So that technology's been around a while. It's a process called photogrammetry. It can be done from the ground or the air. Photogrammetry uses the photos to gather the measurements, and it can create drawings and models. So BIM is another option. It's basically a digital representation of physical assets. Models are developed during construction, and those models can help facility managers better manage assets. So, for example, a building owner may find evidence of a leak in a building, and rather than exploring the physical building, he may turn to the model and see that a water valve is located, in a suspect location, and may be able to identify it that way. And then our AI. AI is basically an analysis of big data. So an analysis of large quantities of data has several practical applications in detecting life cycle trends, and is helpful for maintenance planning and quality control. So collecting the asset condition data. So it's really a fundamental process. So we're basically trying to determine if something's in good condition, bad condition, or somewhere in between. So the definition of what is good and bad will depend on what the owner's requirements are. So for example, some owners may be only concerned with how functional an asset is, but others may be concerned about aesthetics and functionality. So for example, the photos on the right illustrate a facility that has a fair appearance, but is functioning poorly due to some blistering and poor adhesion. But vice versa, a facility could have good functionality but have poor appearance due to, say, excessive fading or chalking. So the criteria of what defines good and bad is going to be defined, by what's important to the owner. So collecting the asset condition data, we've got a few examples in this slide and the next couple. So an exterior finishes example. So in this slide, we see a picture of an exterior facade. So, we would typically, divide the building up into 4 quadrants. This one picture happens to be on the north. So then we identify the sub-items. And so in this example, we've got some stone veneer, concrete seal, and ICB, and some galvanized. So we may need to identify if it meets brand prototype or not. That may or may not be necessary. Then also, a lot of times we'll identify what finish coatings is on the facade. So in this case, there's not a whole lot. There's some water repellent on the concrete seal. There's some acrylic coating on the galvanized door over there on the far right. And then identify the square footage of the components. So that could gather square footage, or it could be a percentage. Some owners would prefer to have a percentage over a square footage. And then the sub items or components will be rated. In this case, it's a 1 to 5 scale, 1 being bad and 5 being good. And that's kind of opposite of, if I'm sure a lot of you are familiar with the property conditions assessments, and I know that scale is opposite, but for this webinar, it's kind of based on 1 being bad and 5 being good. And so hope that doesn't confuse anyone that also does the PCAs, but that's just a difference in, I guess, how some of these assessments are done. And then physical testing, and so that may or may not be required, but in this case, Rylum tube was done on the ICB, and some adhesion testing done on the galvanized door in both those cases was good. And then identifying any defects with the substrate. So example of a exterior paint. So we've got a simple example here of a door. So we may want to identify the service environment. And so service environment could be, is it in a corrosive environment, or it could be the climatic environment. So the coatings could obviously perform differently in those environments. And so in this case, the picture here represents a mild environment. And then to identify the components. And so we've got a door and a frame, and then the surface to air interface. And so with some owners, they want to determine the condition of that surface to air interface. And that's basically the splash zone, or like from the ground up to 1 foot, where it's highly subjected to corrosion due to de-icing salts. And then identify the substrate. In this case, it's galvanized. And then the size of the component. So that, again, could be done, in square footage, or it could be done as a percentage. And then the rating is assigned. And then identify the coating types. And so, as we'll talk about a little later on, knowing the coating type may be necessary for compatibility. In this case, we've got some acrylic and urethane at the surface to air. And then accessibility to the work. In this case, it's easy to access, but in some cases may not be, and that obviously affects the cost of the maintenance work. So next, we've got an example of flooring. So in the picture here, we've got some LVT, and so we've got the surface area for the example here was 2,500 square feet. The rating is too great here because we see some lifting at the seams, and looks like we've got some delamination with the LVT. So the rating that was assigned was a 2. And then we may need to identify the defects. So does it have, mismatched color, cracks, or damage? In this case, there was about 400 square foot of LVT that was identified for replacement. Sometimes we need to identify if there's trip hazards or life safety issues. In the picture here, we don't see any trip hazards. Then physical testing may be done, and so in this case, some RH testing was done and determined it was 99% RH. So as we collect the data, we may need to identify immediate actions that are present on the building. So some examples may be like settlement or perforation of, like we see in the door, how it's perforated. Or excessive cracking of mortar joints, loose stone veneer, moisture intrusion, or branding deficiencies. Also, with flooring, we may need to identify immediate actions such as trip hazards, excessive wear, excessive moisture, heaving, or curling. And so as we collect the condition data, we've got to think about the rating scales. You know, the rating scales are sometimes can be subjective, so that's a very critical process. And so rating scales are developed typically by an engineer or facility assessment consultant to assess the amount of deterioration of each asset. So the scale typically consists of both a descriptive definition or an industry standard. So industry standards such as the SSPC VIS2 provides a visual guide for assessing the degree of corrosion in steel, or ASTM D4214 provides a method for determining the degree of chalking when aesthetics is important. So also, if aesthetics is important, a graduated fade chart, as shown in the top left photo, may be used in assessing the degree of fading. That's a good way of determining how much fade has occurred. So collecting asset condition data typically is repeated every 3 to 6 years, depending on the service environment, but is necessary to obtain the up-to-date conditions throughout the life of the facility. So physical testing, step 3. So physical testing may consist of adhesion testing, especially when assessing coating conditions. And so a few adhesion test methods are available. It may consist of D6677 or D3359, depending on the type of substrate being tested. D6677 is typically used on concrete or masonry substrates, and D3359 is typically used on metallic substrates. Moisture testing may also be important in defining asset conditions. Moisture meters can be used and may include conductivity type meters as pictured on the bottom, or a radio frequency meter as shown on the top. This is especially important for like barrier type wall assemblies where there's risk of damage to moisture sensitive finishes. So some additional tests. So when wind-driven rain resistance is important, such as the case with integrally colored masonry that serves as a barrier wall, as illustrated with the top photo, a Rylam tube test is important to determine the moisture absorption properties of a material. Also, coating thickness is also an important attribute when assessing coatings, as proper thickness can result in lower corrosion resistance or unfavorable wind-driven rain resistance, or shorter life expectancy. Laboratory testing may also be necessary when assessing properties of coatings. Microscopy can be done to determine the number of coating layers or thickness of each layer. Too many layers can become detrimental to a structure in some cases, especially if the coating has excessive numbers of layers or thickness, causing an impermeable film that can retain moisture in certain climates. Infrared spectroscopy may also be necessary to determine the generic coating type. So determining the generic coating type, it helps ensure compatibility with the underlying coating. For example, if the existing coating type is a silicone elastomer, applying an incompatible coating such as an acrylic, could result in a poor bond or premature failure. So floor testing may also be required, and floor testing may consist of moisture testing such as RH, calcium chloride, moisture meters as shown on the left photos. Gloss and hardness may be important attributes for when dealing with polished concrete on the top and bottom right photos. pH is important for overlay of some floor coverings and coatings. And then slip resistance is also important when assessing flooring conditions in custom areas that are prone for slip and fall hazards. So the physical testing data can be summarized as shown in the table, or using like speedometer type graphs to quickly summarize the asset conditions. So for example, the table and graphs indicate there's some concern with adhesion, especially on the front and left elevation, and it's shown in this slide. And also looks like there's some concern with the moisture. Looks like maybe on the right elevation in this particular example. So step 4, this is where it really gets fun. So after the data, the condition data is collected, the analysis of the data is required to summarize all this condition data that we have obtained, through remote technology or through an on-site inspection. So big data is commonly analyzed and automated by some type of computer program that applies algorithms to the data that's collected. So this is one of the hottest topics in facility management, is how to gather, store, secure, and interpret data collected on assets. So owners are typically hiring data managers now, and that's a common practice as they assist in making sense of huge amounts of data. So organizations that are able to, apply effective data analysis to massive amounts of data really gain competitive advantages in their industry. So at KTA, we use a program called CAP, and CAP stands for Coating Assessment and Painting Priority System. And so although the name implies management of coating assets, it can be used for other type assets like flooring, roofing, and other non-tagged assets. So the image on the right shows a data entry page for CAP. And so where the facility maintenance structure is shown, if you can see it there on the left-hand side of that image, so data is entered for each of those sub-items, such as the asset type, the environmental conditions, the physical testing data, also the cost of maintenance for that sub-item is entered, and then accessibility factors, etc. And so that helps us predict the optimal time for maintenance and the maintenance strategy. So some additional data entry views here are provided on this slide, showing the asset maintenance structure sort of on the left-hand side of the chart there. The condition rating sort of in the middle, and then the physical testing data, they're sort of on the right hand side of the top table. All this data is rolled up and is used to determine the optimal maintenance year and the maintenance strategy for the asset. So, step 5, really the heart of the KTA CAP program and many other data analysis programs is based on a deterioration curve that is established for each asset. So how an asset deteriorates over time is really what we're trying to predict. And so the goal is to schedule proactive maintenance at the optimal point within the life of that asset to avoid a reactive call or forego removal and replacement. So, but with facilities that have deferred maintenance, sometimes removal and replacement is necessary. So, deterioration curves are the basis for determining the optimal maintenance schedule, costing, and repair strategy. So, a couple examples are provided on the right. The top is an exterior elastomeric coating, and the bottom is an exterior thin film acrylic coating. So each has different points within the life cycle that for touch-up, for overcoating, and for remove and replace. So for the elastomeric, the touch-up point is around 4 years, and the overcoat point is between 7 and 8 years. So if maintenance is deferred after 8 years, some degree of removal and replacement is expected, with full removal and replacement expected around year 12. So looking in the future, after maintenance gets on a 7 to 8 year plan, removal and replacement would be minimized. So looking at the bottom graph, the thin film acrylic, the optimal maintenance point is around, for overcoating, is around 5 to 6 years. And then similar deterioration curves are available for other types of assets such as, flooring and roofing. But really the expected performance depends on the asset type, the substrate condition, and the service environment. As discussed on the previous slide, the maintenance strategies are typically included for touch-up or spot repair, which is signified by the letters TU for this webinar. Overcoat or overlay is signified by TU plus, and removal and replacement is signified by R&R. So an example is provided here showing a roll-up of the maintenance schedule and strategy for facility number 149. So at this facility, the left elevation was in poor condition. If you can see the floor plan on the top right of the slide, that elevation was really in poor condition, and so maintenance had been deferred on that elevation, and removal and replacement was necessary. So when the data condition was rolled up, $46,000 of work was required in 2021 for removal and replacement. And the facility, but the rest of the facility was in good shape and could be pushed out to 2023, which consisted of mostly overcoating. So by strategically subdividing the facility assets, maintenance dollars can be spent on the assets that really need to be addressed, and then the rest of the facility could be painted at a later time. And that way it doesn't tie up maintenance funds, that could be used elsewhere if this building was all done at one time or 1 year. So just a simple example, showing us how deferred maintenance can be costly. So we've got an image here of some elastomeric paint that's not been maintained, obviously, by the blistering. So instead of overcoating at year 7, like we see in the deterioration curve, for $1.31 a square foot, maintenance is deferred to until year 12, and now removal and replacement is it's $5 a square foot. It's going to cost us $5,000. If painting was done at the optimal time, we would have spent $1,310. So step 6 of the condition assessment process, it basically involves summarizing the maintenance strategy, the future value cost, and the optimal maintenance schedule for the facility, or facility sub-items or components. So this slide shows how this is facility 1909, summarized after being processed in CAP. So the table on the left shows the maintenance is recommended in years 2021, 2023, and 2029, along with the future value cost required for each year by grid or by elevation. The right screenshot is a drill down of the data showing the maintenance strategy by sub-item, along with future value cost and maintenance and the maintenance recommended maintenance year. So we see a combination of removal and replacement, touch-up, and overcoating is required for this facility. So the right table is cut off due to size, but if the entire screen was shown, it would show the breakdown of the right, back, left, and canopy grids. So, for example, the front wall has around $17,000 worth of removal and replacement required in 2021, which consists of the tilt-up, the base sealant, the ICB, the screen wall, the surface-to-air galvanized, and the laminated panels. Similarly, there's about $9,752 is needed in 2021 for overcoating, which includes the doors and the steel. Okay, so this screen represents another type of facility roll-up data showing the condition scores, the optimal maintenance year, and the maintenance strategy. So for this client, the scores are required for the visual and the functionality. So we have a roll-up score. So for the total facility, we see the visual score is worse and is a 2.62 compared to the functionality score of 2.92. Again, 1 being bad, 5 being good. The optimal maintenance year for this facility is in 2022 and 2025. And so instead of square footage, this client chose to use a percentage. So 80% of the maintenance would be done in year 2022 and 20% would be done in 2025. And so the maintenance strategy is indicated under the year. You can see by the letters there, TU plus or R&R. So for the front elevation, the CMU counts for 3.6%, EFIS 92.2, and EFIS 2 is 4.2, all recommended for overcoating in year 2022. Just another example real quick. This screen is just another type of roll-up, and this client represents an alpha grading system, which can be done in CAP. Instead of percentage, this client preferred measurements of each sub-item, which is provided in the following column under the surface area. And then the future value cost of maintenance and the maintenance strategy is shown under the appropriate year. So for this facility, maintenance is recommended in year 2020 and 2023. And then the future value cost of that maintenance work for each year. So another dashboard roll-up, it shows this is facility 6319, has a recommended maintenance year of 2022 and 2024. So 30% of the maintenance is recommended in 2022 as removal and replacement, along with some photos of the removal areas there on the right. And then 11% of the facility is recommended for overcoating in the year 2022. The balance, is in 2024. So step 7 is basically summarizing the portfolio and establishing, the frequency of maintenance throughout the life cycle of the building or structure. So this example shows a simple breakdown of the facility. So the pie graph on the left shows that 5% of the facility has either a poor or very poor condition. And then the graph on the right shows the fleet condition, and it shows that around 18% is either a poor or very poor condition. So you can kind of get an idea of how your facility or fleet portfolio is performing. So another portfolio example. So when summarizing the portfolio, typically a quick comparison of condition scores is necessary to determine what the priorities are. So a couple examples shown here. The bottom example shows that facility L has the best condition at 3.97 and facility DD has the worst condition at 1.22. Some owners, may develop their maintenance budgets on this type of data. Facility managers may, present this to leadership, or may say that any facility, say, that's scoring less than 2.2 would require maintenance funding for the future year. Another portfolio summary example. It may be necessary to summarize the fleet in terms of future value cost of maintenance required for each facility. So in this graph, we see facility E would require $293,000 in 2021. But if we move down the graph to facility W, it requires $197,000 in 2021 and $19,000 in 2022. So the gross maintenance spending can be summarized per year, as shown in this example. So it's likely that this client has a lot of deferred maintenance due to the heavy loaded maintenance costs in year 2021 and 2022. But after 2022, the maintenance spending becomes quite less. So another dashboard roll up that shows how maintenance scheduling, can be summarized by percentages and strategy. So in this example, 47% of the fleet is recommended for overcoating in year 2021, and 15% is recommended for removal and replacement in 2021. Again, likely a lot of deferred maintenance due to the majority of the work being scheduled in 2021. This is kind of a neat graph or map. So the dashboard summary can, show the facility, with the greatest future value cost of maintenance required by dots. So the dots correspond with the highest future value cost. And so we see the facility in looks like Ohio, Wisconsin, and Mississippi have the greatest future value maintenance cost. Pullback summaries. So if you've been in facility management a while, most facility managers are faced with some type of budget cut or pullback at some point. So this can happen, typically, it seems like it always happens in like third or fourth quarter, and requires some quick analysis to figure out where to spend my remaining maintenance funds. So a benefit of condition assessments, it allows facility managers to make quick strategic decisions during pullback situations. For example, if high visibility assets are identified when establishing a maintenance structure, the focus could be placed on maintaining those high visibility assets and defer the remainder of the facility to future years. So, for example, the bar graph on the left shows how the facility on the far left has $72,000 worth of maintenance needed in high visibility areas. The remaining $144,000 is not in high visibility areas. So this means that $144,000 could be deferred to future years and allow those maintenance dollars to be spent in high impact areas. A summary of the graph, on the right, it would take around $131,000 to maintenance high visibility or high impact areas, compared to $560,000 for the non-high impact or high visibility areas for those 5 facilities. So if those types of budget cuts were necessary, then this would be a way to do it. So similarly, facility managers may need to decide, to cut or spend their maintenance dollars that's remaining on, say, the front elevation, or they may decide to maybe just do sealants or EFIS repairs. So some graphs representing that if that was the appropriate strategy. So there's an obvious economic benefit to maintaining assets at the optimal time, and this is what is really this slide is trying to illustrate here. So in this example, the graph shows the optimal maintenance time is at 7 years, and the maintenance cost is at $34,000. So if maintenance is performed prematurely, we have to add depreciation cost to, and it becomes a factor. But if maintenance is deferred, the cost increases due to additional degradation of the asset. So in this example or this graph or this chart, a deterioration curve was used to estimate the cost of the deferred maintenance after year 7. And so we see it gradually increases after year 7. And that is based on $5 a square foot. So we see, if we defer maintenance, say, to year 10, our cost is $43,000 instead of $34,000. So obviously there is a cost for, not maintaining assets at the optimal time. And we obviously see here that there's a cost benefit for doing our maintenance at the optimal time and scheduling our proactive maintenance at the right time. So a well-implemented plan of condition assessments, it allows facility managers to be able to make or defer maintenance without really compromising the brand or the asset condition. So it allows, visibility to spend maintenance dollars on building elements that are in critical need of maintenance. It avoids performing maintenance on assets unnecessarily. And it can allow for maintenance dollars to be spread out to maybe 2 or more facilities instead of one complete facility. So the table on the right, it's an example of how careful, establishment of a maintenance structure allows for the maintenance to be split up into 2 years compared to spending all of it in 1 year. So the previous approach illustrated on the left of that chart shows how the maintenance cost of if the entire facility is scheduled for maintenance in year 2022. If that maintenance is scheduled at the optimal time, the schedule would be 2021 and 2024, as we see on the right-hand side of that chart, which allows, deferred maintenance areas to be taken care of in 2021, and then the remainder in 2024. So the total spent over 8 years is reduced by around $55,000 just by scheduling, the maintenance at the optimal time. To further explain the previous slide, the cost savings, so the photos illustrate the areas that would be required for maintenance in year 2021. So we address these obviously bad areas that are in bad condition and high visibility areas. The remainder of the facility, which is not really pictured here, but the rest of the facility is in good condition, and it can be deferred to year 2024. So this slide illustrates the value of condition assessments compared to a previous approach of scheduling maintenance strictly on last touch date. So I talked to a lot of owners and clients about, how I guess things have been done in the past or traditionally done, but it's commonly practiced to just schedule proactive maintenance on a last touch date instead of using condition assessments. And so there's some limitations to that. So by conducting a condition assessment, if we can see the comparison here, if we're strictly doing it by a last touch date, we're really it's just basically we're adding whatever the schedule is, 4, 5, or 6 years to our last touch date. But if we're doing a condition assessment, we're able to know the condition score. We're able to prioritize. We're able to, determine the optimal maintenance year, which may or may not always be on that 5 or 6 or 7 year cycle. Could be, vary based on environmental conditions. The maintenance strategy and the future value cost of maintenance is determined. So this allows just for more strategic spending of maintenance dollars. It allows us to spend money on assets in worse condition and able to really summarize all this data with just a few clicks. It just gives you a lot more information to provide leadership on what budget should be for maintenance work. So a goal of many facility managers is just to reduce reactive calls and management and really manage assets more proactively. So condition assessments, it really allows you to move your portfolio from a catch up to a keep up. So we obviously want to avoid conditions that are poor or very poor, and that requires reactive work to address, or removal and replacement that's obviously costly. We want to keep it more, toward the other side, or to the left side rather than the right side in this slide. All right, so in summary, condition assessment benefits. It's really, it becomes the asset manager. It really helps manage your assets efficiently, and you have backup of to make decisions. You're able to collect the data, condition data, able to analyze and summarize that data, and provides the optimal maintenance schedule, maintenance strategy, and future value cost of maintenance on a facility level or on a component level. So it allows for immediate, and long-term maintenance recommendations. and it's really trustworthy data that's that's backed by science, that's provides cost projections and budget projections for executive leadership. So you really have a solid plan that is backed up by solid data that you can to present to leadership for approval. All right, so just a little bit about KTA. KTA was founded in 1949, so we've just over 70 years in business. 100% employee-owned company. Headquarters in Pittsburgh. We've got a picture of our brand new building there in the background that we're proud of. So we've got around 300 employees, about 180 inspectors, consisting of PEs, chemists, environmental professionals. There's several business units within the company. Coating inspection. I'm in the commercial services group, and in commercial services, we typically help owners with facility condition assessments, moisture intrusion investigations. We do a lot of quality control and construction inspections and a lot of different unique tests and inspection type work. So with that, I thank you for your time and attention. And at this time, we'll open it up for questions.
All right, so that is the end of today's broadcast. Thank you all for attending. Generally, we would do a question and answer during this time, but given the circumstances, we're going to forego the normal question and answer portion because Kevin has been interacting with you all and answering your questions in real time in the chat. We do appreciate you spending the last hour with us. If you have any questions about anything from today's broadcast or any further questions you'd like answered, we would encourage you to reach out to Kevin directly via email at kbrown, BROWN, @KTA.com, and he'll be happy to assist you further. Thank you again for attending, and have a great rest of your afternoon.